I need, a little bit interaction will be okay. So should we start directly from week 10? Anyone has any doubt in week 10 before we start? Any particular topic? No? Can you all hear me at least? Okay. Okay, so before starting the session, anyone has any doubt in quiz to paper? Otherwise, we will just skip the quiz to discussion and we'll start from week 9 and 10.
No, sir. Please.
Quiz 2 was okay. Okay. Can you see my screen?
Yes, sir.
Yes, sir.
Okay, fine. Shubhangi, how was quiz 2?
Not good, sir.
Not good. What?
There's some
I mean,
I just want to wrong for my some question in my mistake.
conceptual mistake or you just messed up in calculation or something?
It's mistake of calculation, sir. Actually,
Oh, okay.
Sir, I
Yeah.
have doubt in that. Suppose most of the problem is solved with
Hmm.
R3 to R2, right? So I got
I
confused
mean,
in how to set in case of R3 to V. We got one vector space
okay.
and how to build that codomain R3 to
I
V.
mean, that is the same thing. No, not we did
Sorry,
not
not
solve
this.
all the.
Not this
So,
one.
which one are you talking about?
First one only.
First one only, right?
Yes,
So
yes.
V is given, right? Some vector space is given here, correct?
Mm-hmm.
Can you tell me the dimension of the vector space?
Sir, one R2.
So how many free elements are there? There is only
Okay,
one
okay, okay,
condition,
okay.
right?
Only two R2.
Is it?
No, no, no. A plus
No.
B. Acha, you are saying that independent variables, right?
Ha ha ha. Right. How
Four.
many
Four.
independent? No, three.
Three
One
independent
condition,
variables are there.
Okay, okay.
right?
Yes, yes, yes.
Right.
Got
So
it.
D basically I can write A plus B minus C, and A, B,
Correct,
C
correct.
are
So
free.
three. So
So
it's
there
a
are
R3,
three.
right? R3 to R2.
Not necessarily R3, but it's isomorphic to R3. But the dimension of V is three. That is at least clear, right?
Mm-hmm.
And dimension of this is two, right?
Mm-hmm.
So we have two vector spaces for where the domain have the dimension 3 and codomain has dimension 2, right? Now it is given that T is on 2. What does it mean? What is
It,
rank?
it means a diamond image of T is equal to
Hmm.
rank of T
Hmm.
equal to dimension of R2 means W.
Correct. So rank is 2,
2.
correct?
Yes.
Now we know rank height theorem, right?
Yes, sir.
So rank T plus nullity T, that will be dimension of the domain, that is 3, right?
Uh-huh.
So rank is 2. So what will be the nullity?
1.
1.
1. Okay?
Got it.
So that was the question.
Yes, sir. Second one is easy.
Yeah. First one also is easy, right?
Yes, sir. That's I missed that.
Yeah, right.
So please explain this affine subspace.
Which one?
Actually, first one, second one. Affine subspace question. Second one. Dimension of L means a solution space of L, na? Second question. Sorry, third question. Second. Sub question two.
Ah, right. Dimension of L. So dimension of the affine subspace, the solution space.
Solution space, na?
Hmm. So dimension of a affine space means dimension of the corresponding vector subspace.
Correct.
Okay.
Uh-huh.
So basically, it is same as dimension of the null space. That's same as dimension of the nullity. That is exactly nullity of A, nothing else.
Hmm.
Right. So first of all, have you solved this question? What is the solution space? Can you tell me that?
Solution space are need to calculate.
X 0 minus X.
Huh? No, tell me.
X 0 minus X. I knew.
X0 minus X. You are saying this one.
Yes, sir.
Okay. Let me check once. So yeah. So basically, we have to do this row operation on 1 minus 1 and 1 1 1. That we have to do the row operation as it is, and whatever your solution space is coming. So I think you are talking about the null space of it, right? Solution space will be little bit different, correct?
Yes,
So if I solve it, what I will get? The first step will give us so 0. This is minus 1. This is 0. This is 0. Then 0 minus 2, 0 and 0. Correct? Is it clear to everyone what I am doing here?
Yes, sir.
Okay, fine. So this is what I need to do. So even after two things, this will be 0, 0, 0. And then what about this one? We can write it as 0. So this is what we are getting. Right? So what is my solution space then? Solution space is basically x plus z. So x, y, z, where x plus z is 1 and y is 0. So basically x 0, 1 minus x, where x is any real number. So this is your solution space, correct? Is this part clear to everyone?
Yes,
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 sir.
sir.
Yeah. Now, if I just want to calculate the null space, this column is basically 0, 0, 0, right? That is what we need. We just have to focus on the row operation on this coefficient matrix, the A only. So if we do that case, then here it will be 0. So basically x plus z will be 0. So our null space will be x 0 minus x, correct? That is what he was telling earlier. So this is our null space of A. Okay. So this is null space of A and this is our solution space L. Right? So what is nullity? If this is null space, what is the dimension of it?
1.
1,
1.
right? Only one thing is
One.
here. Yes. So nullity is 1. That much is clear. This question is clear. Now
Sir,
what
we
is
have independent variables as a
hmm,
how it came one, sir?
one
We have
only one independent variable here, right? X.
x. Correct. Okay.
So no
And
dimension of that space
and
is 1.
also we can do like that, sir, right? 1 0 minus 1. So we are getting only one element,
Exactly. The
right?
basis is consist of one element. Correct.
Uh,
That's why the dimension is 1.
so
Yeah.
this question was my correct. Second one, sir, I wrote 2.
So I'm going to second one. So L is what I have calculated. L is x 0, 1 minus x. Correct.
Uh-huh.
This we have calculated. Now this is an affine space because you see that the 0, 0, 0 is not in this space, right?
Mm-hmm. Mm-hmm.
Uh, But if I can write this as 0, 0,
One.
So 1 plus our null space of A, right? Is it clear?
No, no, sir.
So if I take any vector from null space, what it will look like? X0 minus x, right? And
Hmm.
some vector plus that space means what? So this is how we write null space, affine space.
Affine space. Correct, correct.
V plus W, right? W is any vector subspace. So this, what this means? This means V plus W, but W's are coming from this subspace. So here this V, this is my V, and this is my corresponding vector subspace, the null space,
Correct.
right? So this is an affine space. And the dimension of affine space, dimension of L is nothing but dimension of the corresponding affine space,
Oh.
right?
Okay.
Corresponding vector subspace. So dimension of the null space is same as dimension of this solution space, because I can write the solution space as an affine space by taking some vector V plus null space, and we know the dimension of null space is basically nullity, that is 1. So dimension of the solution space is also 1. Is it clear?
So, sir, actually, I wrote like that: 0, 0, 0 minus 1. No, 0, 0, 1, 1, 0, 0. That I wrote 2.
No, no, no. Actually,
Got it.
1 is enough, right? Yeah. Anyone has any doubt in this? So this question is really important, because maybe some form of this question again can appear in term. Okay. Because affine space, this part is really important for affine space. Yeah, Purnendu, you raised your hand. You can tell me.
Sir, my question is regarding week 9. I was going through the lecture and it was very laggy. So,
Okay, I will come to it. Okay.
okay, sir.
So I just browsing through quiz 2 once, because we have given an exam, so we need to know what are the questions.
Okay, sir.
Yeah.
So
Yeah.
the inner product question, in the
Mhm.
answer key, it gave that the condition 1 is also satisfied. I'm not understanding how.
Okay. Condition 1. Right. So if I replace both by x1, x2, right? What is the inner product?
So you get x square minus,
X1
sorry,
square
x1 square minus x1 x2
minus x1, x2.
plus x2 square.
Correct. This is what I am getting. Correct.
Yeah.
Okay. So can I write it like this? So this is 2 into half
Mm.
x1, say, okay, anything. So x1 into 1 by 2 x2 plus 1 by 2 x2 square. So this is 1 by 4, right? So 3 by 4,
3 by 4 x2 square.
right? So this part is a square term, right?
Yes, that's whole square.
This is x1 minus 1 by 2 x2 whole square.
Yeah,
And this is root 3 by 2 x2 whole square.
yeah.
Right? Sum of two positive numbers.
Yes,
These two are
got it,
positive,
sir.
so it is
Got
greater
it.
than 0.
Understood.
So this is
As long
just
as
a
you-
little bit manipulation on what we have.
Yeah,
So we can start to write it in square form.
I didn't do completion of squares. That's why.
Now, if you take the second part of condition 1, when it will be 0, when both the terms are 0, right? Both these
Yes, sir.
square
Yeah,
terms
yeah.
are 0. So the second one will give x2 as 0, and from the first one you are getting x1 is 1 by 2 of x2. Now x2 is 0, so x1 is 0.
Yeah, yeah.
So condition 1 is satisfied. Yeah, this was one good question.
Sir, how that condition 3 is not satisfied? Actually,
Okay, so if you interchange x1, x2, what you will get? Are you getting the same thing? So if I write y1,
x2.
y2,
Okay.
and x1, x2, what I will get? Can you tell me?
You will get y1,
y1,
y1
x1
x1 minus
minus
y1 x2.
We are getting y2
Y2
x1.
x1.
y2, x1, right?
Okay. Got it.
This
Because
is
this
not
is now the first
okay.
vector. Correct?
Mm-hmm.
So this may not be same as this.
So, in this case, can we assume if we get a mixture of two what do you call it, vectors, then it will be never satisfied. Can we
Which set
assume
of
like
two
that?
vector means?
The middle term,
Uh,
the middle term is okay from x2 and then y1. It's coming from two different vectors, right?
hmm.
Uh, so if any part coming like this, that means can we assume that it will be this condition will be never satisfied?
Actually, there is only one this mixed term, right?
So one cross term is
One
there. If
cross
there was
term.
another cross term like
There is
y to
then it
x1, then
will
it would
be
be satisfied.
Y1 X.
correct, correct.
Okay.
Understood, no? So if there is a term like x1, y2, right? Then it may be satisfied. Yeah? It depends,
Okay. Okay.
and
Yeah.
it depends on the
Yes.
coefficient.
Yes.
Definitely. Okay. There is no, I mean, fixed rule. You have to check. No, we cannot do any fixed rule for this. Okay. So this is clear, right? This question is clear. Question number 5.
Yes, sir.
Can you please complete that affine space question?
Yeah, I have completed this, no?
No, sir. Only 2 questions are
Oh, you want me to solve this also?
C and D. Yes, sir.
So, yeah, what is W now? W is defined as
Linear transformation will be sir, 0.
so 0 x minus z, right? And your W is basically your null space, right? That we have calculated. W is the null space, correct?
Correct.
Ah. So this is your W x0 minus x, right?
Yes.
Now we have to find what is the rank of this. Can you tell me what is the rank? Of
Yes, sir. 1 plus rank of T equal to means null space of T plus rank of T equal to
what is
dimension of W.
null space of T? First, tell me what is null space of T.
Null
What is null
space.
space of T? If you are planning to apply rank theorem, then you first know what is the null space, right?
Null space.
So those
Zero.
vectors which are going to 0, 0. So first term is already 0. So for second term, x minus z is 0 when
X should be equal to Z. 1.
right? It should be equal to z. Now it is coming from null space, right? The nullity of A, null space of A, right? Now the vectors W, the vectors of W is of the form x0 minus x, right? So when it will be the first coordinate and last coordinate will be same, it will be equal only when x is 0, correct?
Okay.
Do you understand what I am saying, or should I write clearly?
Yes, sir.
So what I am saying, so W I got like this. Okay, this is my W, and the linear transformation, which is saying this is T from W to R2. This is 0 x minus z, correct? So I want to find what is null space of T.
T.
So it is xyz such that T of xyz
Equal to 0, 0, 0.
0, 0.
Sorry, 0, 0. Correct. And we will get 0 only case of x equal to Z.
Exactly. Right. So this is x minus z equal to 0. That means
X equal to
x,
0. X
y,
equal to Z.
and x. This type of thing is coming, right?
Correct. 2.
Now these vectors are coming from where? These vectors coming from this domain, right? And the domain, every vector is of the form x0 minus x.
Correct.
Right? So this second coordinate is 0. It must be 0 because these are coming from W. And these two, so the condition of null space of T is saying that the first and third coordinate should be same. Right? Now when they will be same, when x
They
and
will be
minus
only in case of 0.
when 2x is 0, that is x equal to 0. So basically our null space is nothing but 0 vector only. Correct? So what is nullity of T?
Nullity of T is 0.
0.
Empty.
Correct. Empty. Correct. So no, not empty. 0 vector.
No. 0, 0.
0 vector. So nullity is 0. So now if we apply the anti theorem for this, what is the dimension of the domain? Dimension of the domain was?
Dimension of domain was 1.
1. That is dimension of W. So it is 1. Now nullity is 0. Now you can find what is right. Correct?
Mm-hmm.
This is what it was answered.
Got it.
Clear?
Yes, sir.
Okay, fine. And the last question is also so M cross N is the matrix or the linear transformation.
This is for W.
So, so W to R2 we are getting this linear transformation. W is of dimension 1, right? And R2 has dimension 2. So it should be a 2 cross 1 matrix, correct?
Yes, sir. Correct.
Because R2 has dimension 2, W has dimension 1. So it is a 2 cross 1 matrix. So M is 2 and N is 1.
2
So
plus
what
1.
is M plus
Correct.
N? 2 plus
Yes.
1, 3.
Got it. Sir, in the next fourth question, actually, sir, I got that coefficient of basis, sir, I think I got wrong. That's why that calculation was also wrong. Fourth question.
Yeah.
I got.
So you should. So I mean, this is not very difficult, as I am saying. Right?
Sir, for fourth
So,
question, sir, is there any easy way to find that coefficients?
this is the solving equation.
Yes, sir.
So how we are doing it? So let me start with this one. Say this is what my transformation is. Correct?
Yes, sir.
Okay. If anyone is feeling any difficulty in understanding this, please stop me and ask. Okay. So what is
T of 1 1
T1
is, sir, 2 0 4.
Okay. 2 0 4. Correct. And what is
1 minus 1 0
0
2
2
2.
2 3 minus 1 2. Correct.
Yes.
Now I have to write this in terms of this.
Yes, sir.
this
Correct.
vector.
Yeah.
So let me call it A111 B110 plus C minus 100. So basically, I will do the second one later. So A plus B minus C, then A plus B, last one is A, right? So the equations are A plus B minus C is 2, A plus B is 0, A is 2, A is 4. Correct? I am equating this with 204. So these are my equations. Now A is 4, we have already got this. So
C
B
equal to minus 2. Got it.
So B is minus A, so B is minus 4. Right? And then A plus B is 0 basically.
You can put
C
that 0 also. C equal to minus 2.
Right, C equal to minus 2. So this you got ABC. Now for this one again, this combination will be same. So equation will be only replaced by this B vector, the last one. A plus B is 2 and A is 2. Right? So now what are these? So A is 2.
Equal to 2, B equal to 0.
B equal to 0 and then
C
what
equal
is
to 2. No,
C
2 minus 2.
No, C equal to 2.
Yes, sir. 2.
This is minus. C equal to 2. Correct? So if I write this, my matrix will be 4 minus 2, 2 0 2. Now we have to calculate whatever is given. Right? Understood?
Yes, sir. Sir, actually, this I got coefficients correct, but that last one I got wrong. Minus 2, it should be.
Yeah, I got that wrong as well. Instead of minus 2, I wrote 2 and for B.
So A plus D plus E.
A plus D plus E is 2.
4 minus 2, that is 2. Correct. So this is 2. Yeah, so I mean, this is not very much calculative as you can see. I mean, we don't have to solve the equation. No way we know.
Because the steps were exactly the same what I followed.
Exactly.
It's just the calculation which got wrong, and I think one value got wrong, so everything goes wrong.
Yeah. Okay, but that question has how many marks? This is what marks?
2 marks.
So
that is one of the issue even I am facing, because even though we understood the concept and we were able to answer, somewhere if we make a mistake in the digit, or a calculation, the whole mark is gone.
That is for few problem, not for all the problem, right?
No, the particular question. So
For this particular question,
yeah, because the testing, what I mean to say that even though, because the purpose of the test is to whether we understood the concept and we are able to
yeah,
solve it,
exactly.
right?
Right.
So
Yeah, I understand.
now it is only focused on the just one answer.
Right. But that is the difficulty in giving this MCQ or any type of question. If I can give you to write the solution, then it will be much easier for you to get the part. Yeah, and this is directly from the definition, right? What is equivalent? This, right? Anyone has any doubt in this question?
Yeah, I think I selected the ones, and out of that, one is wrong. So, which means I lost the entire marks here.
Okay. Which one have you selected on?
So I selected condition one to be wrong, false. I didn't select that. Instead, I selected 2, 3, and 4 to be right, and I got it all wrong because 2 is not the right answer, right?
How you can select 3 and 4 together? They are just contrapositive statement, right?
Yeah, I realized it later once I was going through
And
it.
3, 4 cannot be correct together. Right? Okay. And but you should select the first one as the correct at least, because that is the definition
Yeah.
of equivalent matrix. Yeah. Okay, fine.
I think in this kind of questions, it's like ones which you are absolutely confident about, just select that and leave the remaining ones, even if you're,
Right.
This one I got right. Yeah, this one is fine.
This one is fine. Question number 7.
Yes, sir. Please explain this.
So
The same thing now. V vector space here we have two independent variables, so it will be R2.
So don't call it R2. This is a defined vector space which has dimension 2.
Sorry, dimension 2.
Dimension 2. Yeah. Now, how T is defined, you can see, right? X plus Y and X plus Y plus. So, what is the nullity of T? Let's first consider that one, right? So, all those X, Y, Z for which, so this is nullity of T.
Sir, so it is easy, sir, right? To calculate the nullity because we are directly putting the zero values.
Right. So
always
basically
start
we are
with
getting
nullity.
Yeah. Right. That's why we calculate nullity first.
Yes, sir.
Because that is the solution of the homogeneous system.
Yes.
It will be
since nullity is not 0, so we can say it's not 1-to-1. So that rules out.
So have you checked nullity is not 0? So that is what
we
intended to check. Yeah. So basically, you got this, right? So y is minus x. This is one thing, and then z is 0, right? This is what we got. So it is x minus x 0, correct?
Yeah.
This is the sorry, no, we should call it null space now. Null space.
Nullity will be 1.
So nullity will be 1.
Yeah.
So it is not 1-to-1. That is clear. Now what is rank?
Rank will be, sir. It will be 2.
2.
Because the domain is
rank and the domain of dimension of V will
dimension
be
of codomain is same. So that's why it's
so that's why it is
1, 2. Yeah. So that this is the only problem I solved confidently.
Okay.
So, sir, in such case, suppose in linear transformation, either V or W, they are not given directly. Suppose, so we have to create check independent variable.
The dimension of that.
Sorry, dimension.
Yeah.
Dimension on basis of dimension, we can conclude it is R2 or R1.
Don't call it R2 or R1. This is a defined vector space. You just focus on dimension. You don't need to call it R2 or call it R3 anything. Just you need to know what is the dimension of it, and that is what we are using, nothing else, right? Yeah, that is what it is.
So dimension means you are saying we are putting 1 and 0 both the values, right?
What is dimension? Dimension is basically the cardinality of his basis, right?
Correct.
So if I take this one, how many free variables are there?
2.
2. So dimension is 2. Because if you want to write the basis, what you are telling, I think
1 1 0
1
0
0 1 0. This is 1.
and 0 0 1 1.
So what is the cardinality of the basis? That is 2.
2. Sir, suppose we want to write in R format. So it
Why
is.
you want to write it in R format?
Yeah,
You can write it in R format, but then you have to give an isomorphism from V to R2, right? Because this is of dimension 2, right? So yeah, I understand that there is an isomorphism, but that is not direct. Right? So basically here isomorphism, here it is easy. So from R2 to V, can you give me an isomorphism?
R2
As you are telling. V.
V.
So take TAB as this. This is the isomorphism.
Correct.
If I give you this linear transformation, then you can check this is 1 to 1 and on both. Then you can say that V and R2 are isomorphic to each other.
Isomorphic. But it has rank means high. Rank no, dimension.
Both of
In
them
question
are
it is R3 given, that's why.
so this part is different. So this is different. So let me call it U. This is a transformation U, which is isomorphic. This is not this T. This is different T. Different.
Okay, sir. Sir, in 8th question, in one of the lecture by Smita ma'am, she had mentioned determinant of orthogonal matrix will be 1. So how
minus only.
minus?
Plus or minus 1.
Yeah, we can prove it by. I mean, we can prove it by the theorem that is plus minus 1, because A transpose is A inverse. So like this, we can prove it.
No.
This is what we know, right?
So determinant of A square is 1.
Square.
Means that has to be plus minus.
So this is
Six
determinant
one.
of identity,
Determinant
that
of
is
I
1,
will be
right?
1, correct?
Then
Got
this
it,
is
sir. Got it. A square,
So
if there is
square,
a
it will
square
come
root.
as square, right? Yeah.
Square root.
And this has same as determinant A, so determinant of A square is 1. So determinant of A is plus minus 1. Okay?
Yes.
This is what.
Got it, sir.
Understood?
Yeah.
So this is basically your quiz 2 paper. So
Sir, out
as
of
we
all
have
this
this-
question, only that affine subspace question was a bit tricky. Another question was easy.
But now is it clear? Affine subspace question?
Yes, sir. Yes.
I missed the initial
Sir, in
part.
next one of the in any sir live session, can you just explain in detail like you did for equivalence matrix?
Affine subspace?
Yes, sir.
Okay, I will take a session on
Yes, sir. Yes, sir. It is one of the important concepts.
Yeah, I will take this. Okay. Yeah, someone is telling something. Who was that?
No,
Sayan, are
I-
you telling something? Oh,
I was just saying
yeah.
that I missed the initial part of it. I just checked your email now, so I joined.
Oh,
But I can go through the recording. That's fine. If I have
Yeah.
questions, I'll write to an email.
yeah, you can write me if you have any questions. Okay. How was your
Sir,
quiz,
are we
Sundar?
going?
Quiz was okay. I don't know how I did because I didn't want to check the answers. The only thing which I checked is this bit, the A B C D E F matrix, which I got wrong because I realized as soon as I came out, I realized that the calculation was not right. So I missed one calculation wrong, and then the entire question became wrong.
Actually, I checked some of your marks. I mean, for those who I didn't remember the names, I have checked your marks, but now I forgot how you got.
So you would
I
know
have
better
already
than me
checked.
how I did.
I have to check again.
Sir, mine actually 3 questions were wrong, sir. All others were right.
See.
So 8 marks I lost.
Okay. 8 marks in 25, is it?
25, yes. 3, 3 and 2. That on
Okay.
to T is on to and 1, 1. No, that one I thought both are. I put it as neither on to nor 1, 1 because
This one.
nullity was not 0. Yeah, nullity was not 0. We are sure that it is not on to, but 1, 1 I couldn't.
Nullity
Because
non-zero means it's not 1 to 1.
It's not 1-to-1.
yeah, not 1 to 1, and since it is x plus y, I mean your what do you call rank is 1.
Rank is 2.
Rank is 2.
No, now only I was seeing this, but what I thought is rank will be 1 now, sir. For x plus y, both are same.
No, so here it is the mistake. Rank of not this matrix. Rank of the transformation I am calculating.
Yes,
I'm not
sir.
calculating rank of the matrix, right? So
Yeah,
here
now
I am
I
using, yeah. So these two are different rank.
yeah.
So
This
that
I
What you
saw,
are
and then
saying
it all
that,
it is one. Then so it is not. Then it is not 1-to-1. Also, I mean, on to one to one. So I
but
marked that one
that does
wrong.
not give you anything. If you calculate rank of
Yes,
this
sir.
matrix, it will not give you
so
anything.
in this case, can we say that the transformation is R3 to R2? Here in the question it is given as V, but
Not
that V
directly
is
to
eventually an
R2.
R2.
No, it's not eventually R2. Basically, I can give an isomorphism from V to R2. That is this one. So there we need to give an isomorphism from V to R2. V and R2 are two different vector spaces which have same dimension.
Okay.
Right? They are not equal. They are not the same vector space. But they are isomorphic. That we can say.
Right.
Okay? And that is the isomorphism we can give there. Okay? So V is not R2. They are not same. V and R2 are not same. They have only same dimension and there is an isomorphism between them. They are isomorphic. But isomorphic and same vector space, these two are different things. Okay.
For me, that affine space full mark I got, sir. All four
Oh.
questions were right. One more thing, what I got wrong was that Smith's that norm of W. That question was wrong.
Oh. Okay. But that was, I think, easy question, no?
Easy only. I wrote it as 2, sir. 3
Oh.
is the answer. I got wrong that one. Those 3 only are wrong. Otherwise, all are. But 25 marks is very, very small, sir. Last time, maximum there were 50 marks. But 25 means one wrong also into 4 times in 100 it will
Times,
go away.
yeah. But if I do it, so there is one dichotomy between us. So if I give you a 50 marks question for maths 2 on this type of concept, then the question may be a little bit lengthy, right? Then you have to focus on each question and you don't get enough time to think.
Time to do it.
Right? Because the time is 1 hour, right? Whether it is a
Yes,
50
sir.
mark paper or 25 mark paper. So what
So
I think
Sir,
25
I
mark,
think we.
yeah.
the only way
Sorry.
to deal with it is maybe just give marks for the ones which are selected correctly rather than making everything wrong.
Taking everything wrong is what? MSQ time.
Because if out of four, let's say if we have selected 3 options and out of that 3, the other 2 is right, we lose the marks for the other 2 as well.
So now here one thing I can say. Suppose everyone is giving all the 4 options as correct option. Then.
Yeah, I know.
Previously, someone was telling, if you're out of 4, if you feel 3 should be right, whichever one particular thing which you feel is pakka right, then you mark that only one,
Exactly.
at least 1 mark you will get.
Then you get part marks at least.
Part marks, at least 1 mark you can get. So that is there.
So ideally, I think we should have not all the questions should be the similar to like involving a lot of calculation. We should have a mixture of questions which we can answer in 1 or 2 minutes.
There is no much calculation is required, as you have seen, right? So I have discussed this question within 20 minutes, right?
Yes,
so lot of calculation I have done basically.
What I mean, sir, that why don't you increase the number of questions?
So
what I mean to say, why don't you increase the number of questions? To make sure that everyone understood the concept. So you maybe one in 1 or 2 minutes we can answer those questions. So then it will be distributed, not everything related to the calculations.
That is my point. So I am saying. So what do you feel? This question has too many calculations. That is what you are felt. Jalish?
No, it is not too much, sir. We are
No,
able
sir,
to
like
finish this faster,
comparatively-
actually, sir.
Time-wise,
Yes.
this was
I was able to finish this faster.
It's a lot of scope for same mistakes. Numerical.
Okay, understood.
Backup papers. Yeah.
So in end term you will see
sir,
a 50 marks paper, full 50 marks paper in end term you will see.
Sir, end term will be, sir, more focus will be on 9, 10 or 11, or it will like...
No, don't break it like that.
Because sir, 9, 10, 11 are
New.
It's not linear algebra, na?
It's new. It's multivariable calculus. But
Uh-huh.
don't focus on only that 9, 10, or 11.
No.
Because
We'll focus on
they are.
everything, but
I mean,
most of the
if you have
question I think
seen,
will come from 1911, right?
that is also not necessary. I will not say that.
Okay.
Okay.
No,
So if
what
you
he
have
is
seen,
asking or what we are asking is what will be the breakup of 100 marks or 50 marks, sir?
that
1 to
so
4,
yeah, that
5,
is what.
6,
Yeah, I
5
understood
to
your
8?
question.
Yes, sir. Yes, sir.
So if you have seen the questions of earlier year, so I think some of you have seen it. Maybe all of you have seen it, the question of earlier year. So there were some question which a single question consists all the concept of from week 1 to week 11. There was a question like that. So I cannot break up that question like this, right? So it is difficult for me to breaking up the marks like that. So this time also you will get one question like that. That I assure you. There will
Sir,
be a question
in this
which
quiz,
will. Huh?
sir, in this quiz 2, we got one direct question from week 1 to week 4, and other questions are indirect
Yeah.
from week 1 to week 4.
Right.
Yes, sir.
So that will be again happening in.
But sir, up to week 8, it is linear algebra, and 9, 10, 11, it's
No, I can create
calculus.
a question. I can create a question which will relate calculus portion with linear algebra.
Algebra, right? Okay.
It's like
So
the
I am
affine
giving you
questions.
exactly right. So if you see the tangent plane of something, right? So tangent plane is basically nothing but an affine subspace, right? Now I can relate it with the whole week 1 to week 8. I will just give you a surface. I will ask you to find what is the tangent plane of it at this point. Now, if I take two such tangent plane, I can ask you the solution space that will form a affine space. Then I can ask you the null space of that. Then I can break a question like this, and that will cover whole week 1 to week 11. Right? Understood? No,
I
what
think,
I am saying.
yeah, I think the last lecture we stopped at the equivalent and similar matrices, right? Are we going to continue from that point onwards, or?
No. So today, basically, I was trying to focus on start from week 9 and 10. I have selected some question. Then we discuss that. Okay.
Oh, we are not doing week 8.
No, we are not doing week 8 today.
Sir,
So I
please
will take
start
another
of
session
week 9,
on
sir,
affine
like
space
live
later.
session. Live session, means not in detail, because that week 9 and 10, week 9 was not taught by you and ma'am also. So we are not able to understand it correctly.
Oh.
Yes. Means not in great detail like you did for all other weeks, you and ma'am.
The
Okay, so I
second
have some
video
questions.
of week 9 was lagging, means I watched the second part, but
Okay.
it
What
was,
is
means
in
you
the
were
second?
writing something. It was like, means you were saying something about path, but the equation was not there. Then the graph was not there. You
No, I
said
have not
something.
taken any session on week 19.
No, sir, you have not
But
taken in week
actually,
9.
the live session of week 9, the second live session was lagging.
Okay.
Yes, sir.
Okay, so today what I will do, that will cover all week 9 and 10. Okay, let's start.
Okay.
Otherwise we will get late. Okay. So we'll try to cover all the concept more or less. Okay. So let me start from there. You have an idea what is multivariable function, right? So you have already got an idea what is multivariable function. Can someone tell me that? Just what is a multivariable function?
Which has more than one input, like x, y, or
No. One variable.
one, like.
Right? Yeah. So there are two types of function, right? One is multivariable function, and so vector valued function is another thing, and scalar valued function is another type of multivariable function. Right. So basically, if I say x, y, z, and if I take it as x square and x, y, and z, this is multivariable function, but this is vector value, right? Because the output I am getting, that is a vector. Correct? Now, if I
Yes, sir.
take this type of function, x square plus xy plus z, suppose this function, this is scalar valued function because the output I am getting is in R, is a scalar, right? So
Yes, sir.
basically, in our course, in our syllabus, we will focus more on this type of function, which is from some Rn to R, scalar valued multivariable function. right? So this is what we will focus more on. Now in maths 1, when we
So,
have done, yeah,
sir, here the R represents a point here, right?
R is set of real numbers. The R
R
is
is
one
actually a
R.
scalar. I mean, output is scalar, sir, right? Which
Huh,
lies on the real line.
real line, right? So this
Okay.
is set. So when you write a function like this, R to R, what you have done? This is in one variable function, right?
Mm-hmm.
So
So
that we
fx
are taking
is
input
x square
from
plus
R and we are getting
rx.
output
And
as
output
in
in
R
R.
as well.
So this is a single variable function, correct? This type of function you have seen. Or say fx equal to mod x. You have seen it earlier, right?
Mm-hmm.
This is one variable function. So here I am
Yes.
taking input as a scalar and taking output as also as a scalar, right?
Hmm.
But in this case, I am taking input from Rn. You
Hmm.
know what Rn is now, right?
Yes.
N variable, the function with n variable, the input from n variable thing, and the
Hmm.
output is a single variable. Output is just one
Okay.
scalar,
So
right?
it's
That is
just a
what
scalar number.
exactly, exactly.
Okay.
So if I take this, say if x y z, this what I have written x square plus xy plus z. Suppose I am giving you an input 1, 1, 3. What is the output? Just simple calculation. 1 plus 1
4.
plus 3.
Oh, sorry, 5,
5.
5, 5, 5.
5.
5.
So I am getting a scalar as my output, a real number, right? So this is in R.
Yes.
So that is what I have written. Okay.
Okay.
Okay. Now the interesting thing is, so in one variable function, the first thing we have done to understand calculus, that is limit and continuity, correct? Limit and continuity. So here also we will limited the same type of thing. Now if you remember how we have done limit for one variable function. So suppose this is a graph of a function, okay? And I want to find a limit of this function at this point x equal to a. How we have done it? Do you remember?
So left hand limit and right hand limit we calculated.
Correct.
If they were equal, then we said the limit exists at that point A. X equals A, sorry.
Exactly. Exactly. So we are approaching this point x equal to a. So there are two ways we can approach the point because we are on a single variable thing, right? So on this x-axis, I can approach from left and right. There are only two ways to approach the point x equal to a, correct? On a
Yes,
real
sir.
line. So there are only two ways. But now the interesting thing is happening here. Suppose I am taking a function from R2 to R. Just I have increased one dimension. I have gone to R2. So when I am drawing this function, this plane is my R2 and I am plotting my output in this Z axis, along this Z axis. Okay. So I am taking input like this and I am getting a output. So suppose this is what now. So now suppose I am saying what is limit of fxy. What do you understand by this limit? A comma. So now I am talking about point on R2. So let's fix a point A comma B here on this plane. So this is A comma B. Now if I want you to approach the A comma B, how many ways can we approach?
So infinite number of ways
Infinitely
because the
many.
entire plane is the domain.
Exactly. Exactly. Right. So now my output, my plot will be like this, a surface like this on Z. Right? This is my surface, this is the output. A sheet like this. Right? For one xy, there is a point fxy, another xy, there is a sub point, another there. So these are all outputs. Suppose they are lying on this sheet, this surface. Right. Now, when I am approaching this AB, there are infinitely many ways I can approach. Right. So these are called path to A comma B. There are infinitely many paths like this, and this path can be straight line, they can be parabola, anything, right? Even some path which we cannot give a name, some arbitrary path. So if the limit of xy tending to a comma b, if this has to exist, then what does it mean? It means that if we choose any arbitrary path, all the values should be same. Now in earlier case, for one variable case, there are only two ways, so we can check directly. But here there is no way to check for all the path, right? Because there are infinitely many. How many we will check? We cannot check for each path, right? There is no way to do that. Understood?
Yes, sir.
Okay. But here checking
Yes, sir.
limit does not exist will remain the same. We have to find two paths for which the limiting value will be different. Then only we can say that limit does not exist. The negation statement is still the same. So in one variable, what we have done, if left hand limit does not match with the right hand limit, then we say the limit does not exist. Here also we have to find two such paths, at least two such paths, for which the limiting value will be different. If I can find two such paths, then I can conclude the limit does not exist. So from this infinitely many paths, I only need to find two paths for which limiting value of the function will be different. If I can do so, then it is clear that limit does not exist. Is it clear?
Yes, sir.
Yes, sir.
Yes.
Anyone has any doubt till this point?
No, sir.
Okay, great. So suppose this limit exists. Okay, suppose this limit exists. Then the next point is continuity. Right. So in case of single variable, what we have done? So first limit extending to a plus fx, it should match with limit extending to a minus fx. If this happens, then we call that limit exists. Limit extending to a fx, that will exist. And then for the continuity, there are two conditions. First, limit has to exist. Then that should be equal to the
F of
value
a.
at that point, f of a.
Value.
Then we call that function is continuous. Here also the same thing. This should exist and it should be equal to f of ab. Then we say that function is continuous. So can you see the analogy between single variable and multivariable? Okay, so only the different thing which is coming here is basically there are infinitely many ways to approach a single point. That is the main difficulty in multivariable calculus. Okay, so here the important way to check for a limit is basically sandwich theorem. The same sandwich theorem what we have done for single variable. Here also we can do it. Okay, so suppose I have two functions gxy and hxy, which is a bound for my original function. Right? Now, if limit of these two functions is known, suppose I know that these two limit exist and these two limit are equal for g and h, then this function always lies between this g and h, right? So at the limiting point, at that particular point a comma b, this limit should exist, they should match, right? So what will be the limit? The limit will be the same of that, those two. Suppose this is L, then this will also be L. So this will be an important tool to find the limit of some multivariable function using sandwich theorem. Okay, I will show some example how we can do it. But as a concept, is this clear? That what we have to do for finding the limit?
Yes, sir.
Okay.
Yes, sir.
And one just important thing to remember that whenever I have this type of function, the polynomial type of function, right? Nothing rational, just x square y, x cube plus x4 y, y cube, whatever, this polynomial type of function, all the powers of xy are positive, right? If I have this type of function, then limit will always exist at every point for polynomial function, and they will be continuous also. Okay, for a polynomial type of function. Okay,
Okay.
because if we take suppose this function itself, suppose this, take this function, what I have written here is 4, and I am asking you what is limit of xy at the point 1 comma 2, then there is no point of break at the point 1 comma 2, right? This is a polynomial, nothing else. So we just put the value of that function there at 1 comma 2. What will be the limit then? 2 plus 1 plus
2.
I. So the limit will be 5, and this function will always be continuous. The polynomial type of function. We don't have to bother about it so much. Okay, understood?
Yes, sir. It's
Okay,
like the
sir.
basic exponential log and polynomials,
Exactly,
they are continuous.
exactly. The same type of thing will happen here also. So now let's do an example. So can you see this problem? Up to r, I have taken a function. It is defined case wise. So how it is defined? So at origin it is 0 when both x and y are 0. That means at 0 comma 0 it is 0. But other than origin it is defined like x cube by 3x square y, something like this. Okay, other than 0 it is defined like this. Okay, so my question is it continuous? Is it,
No,
first of
sir.
all, limit
No,
exists
sir.
at 0 plus?
Limit doesn't
Why?
exist, sir.
Limit.
So it's path dependent.
For
Okay, how?
different direction, we will get different values.
Can you
Yes, sir.
give
It's
me
path
two
dependent.
different paths for which the limit will be different?
So y
Mm,
equals mx you can take for the first path, and second you can take any polynomial kind of path. Let's say y equals x square
Okay, so let me
or
just
something like that.
write it. So this is x cube by 3x square y, and xy are non-zero, so I can cancel x square. First I can do this. So this is when xy not origin, and this is 0 if xy is origin. This is what it is given. Now what they are saying, that suppose I take y equal to x path. This is a straight line, correct?
Yes, sir.
So I can approach my point 0 comma 0 by this path, right? Because this point lies on this path. So I can go to 0 comma 0 by y equal to x path. So if I take y equal to x path, what is the functional value approaching to? So in place of y, I will put x. So that will give me 1 by 3. The functional value will be 1 by 3 all over this path, y equal to x. So when I am approaching to 0 comma 0, the functional value is constant. It is always 1 by 3. So the limiting value will also be 1 by 3 if I approach via this path. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
See, if I change the path, if I take y equal to 2x path, okay. So again I put this y equal to 2x in this. So what I will get? I
1
will
by
get 1 by
6.
6.
1 by 6.
Again, so when I am approaching by y equal to 2x, so 0 comma 0 is again on the path y equal to 2x, and I am approaching to 0 comma 0 by this. The functional value is always constant, 1 by 6. So the limiting value is also 1 by 6. But it cannot happen, right? If limit exists, then via every path it should be same. But it is not same
Yes,
in this case. In this case,
yes, sir. It's not unique.
it is not unique. So limit does not exist. Is it clear?
Yes, sir.
Sir,
Yes,
can
sir.
you explain this last part via y is equal to 2x1?
So what I am doing, so let me draw this. So there is the point 0 comma 0 on xy plane. So it is basically 0 comma 0 comma 0, but on
Yes.
xy plane it is 0 comma 0. So if I approaching via x equal to y path, suppose this is x equal to y, I am approaching 0
Okay.
comma 0 by this. Okay. So how our functional value will behave? So along this line, x and y are equal. Correct?
Yes.
So our functional value is always 1 by 3.
1
on
by
this.
3.
Now if I approach 0 comma 0 by this path, our limit will be 1 by 3, correct? Because functional value is
Yes.
constant along this path.
Hmm.
So this is via y equal to x. Now, if I approach say x equal to 2y, this one, via this path, okay, then how our functional value will behave along this path?
X is 2y, so
Sorry, not x is 2y. I should write y equal to 2x.
Y
y
equals
equal
2x.
to 2x. Yes, that I was.
So, what will be our functional value?
6.
1 by 6.
Yeah, 1 by 6.
Right? 1 by 6. This is via y equal to 2x. So if I approach 0 comma 0 via this path, y equal to 2x, the limiting value will be 1 by 6 because it is constant through all over the line.
Yeah, but left hand limit and right hand limit are
So
not.
here there is no left hand or right hand. So the point is, by two different paths, our limiting values are different.
Different.
But if limit exists, then via all path limiting value should be fixed, should be unique, which is not happening here. So limit
Yes.
does not exist. Clear?
Yes, sir, it's clear.
Yeah.
Sir,
But
one
for
doubt.
this function, means this path, we can take any path. Means
Yeah,
we
you
can.
can take any path.
Okay.
You can take any path.
Just it's that the value should not be same to contradict.
Exactly. To contradict the statement. Yeah.
And what you were
So
So
the
just
limit does not
saying
exist.
previously, and what you were saying previously about some function that always limit will not exist for that type of function.
Yeah, right. Yeah.
sir, just a small
Anyone has any doubt?
question.
Yeah.
Just a small question, just a general question. I mean, sir, when did you ask about the give me some path? So I said like y equals mx. So my question is, if we take y equals mx, that means we are taking every possible straight line. So it is actually
Exactly.
dependent on m. So we can say it's path dependent. So is it
Exactly.
enough just to prove that? I mean, for particular this question, or we need to take another path and show that the limit is not same
So
and something like that?
for this particular case, for this
Huh.
example, if you see, straight line is enough, right? Because for different
Ha
straight
ha
line
ha.
we are getting different values.
Hmm,
But
hmm,
there
hmm,
may be
hmm, hmm.
some question where
Hmm.
for every straight line you are getting the same limit. Still,
Huh.
there is a chance there are some other path which is not a straight line. For
Hmm.
that we will get different limit. There can be a
Ha ha
situation
ha.
like that.
Okay, okay, okay.
Right?
So,
Then
sir,
you may
that
have to consider some
ha,
parabola y equal to x square or y equal to
yeah,
x
yeah,
cube.
yeah. Ha, ha,
Right?
ha. Okay,
That you
okay.
have to
So,
see.
okay, huh. Okay,
And
okay, okay. So,
so
so
one
that's exactly
small
what I was asking you.
uh, one small trick to understand that, visualize that. So here, this type of function is called rational function, okay? Because this similar to the rational thing, right? P by Q number. Right? So this type of function is called rational function, where here you can see that what is the degree above? 1, right? What is the degree below? It is again 1.
1.
So degree of the denominator, degree of the numerator are same. So for this type of function, y equal to mx will work, straight line will work, right? Suppose
Huh,
I
yeah.
am this type of function. Now the degree of the above is 2, and degree of below is 1,
Above is 2,
right?
below is 1.
So in this type of situation, there may be maybe a possibility that you should consider some parabola y equal to x square. Then it will be different from the straight line. Okay.
Okay,
So
sir.
if I
Got it.
take this example itself, so let me show this one. Fxy x square by y if xy not origin and 0 if xy origin. Now if you take any straight line y equal to mx, okay, and approach 0 comma 0, what is your limiting value?
So it would be 0.
It is 0, right?
Yeah.
Has everybody clear out that?
Yeah, x by
Yes, sir.
m. So
Yes, sir.
putting limit 0 to 0.
So x square by mx,
Mx.
whatever m value you choose. So it is basically x by m. Now I am approaching to 0 comma 0, so x is approaching to 0. So it is 0 by m for whatever the value of m is. So it is 0 by every straight line, right? So
Yes, sir.
when I am approaching by any straight line, it is always 0, but that does not guarantee that limit is 0, because there may be some other path which is not a straight line. Let's consider this path, y equal to x square. This is a parabola, right? And via this
Yes,
path
sir.
also I can approach 0 comma 0, because 0 comma 0 is on this parabola, correct?
Yes, sir.
Yes.
So if I put this on my function, what is my functional value?
1.
1.
1.
X square by
Which
x
is
square,
not
that is
equal.
1, right? Now what is the limiting value? Is 1, correct?
1.
Which is not same as that limit when we are approaching a straight line. So I got two type of path for which the limiting value is different. Understood?
Sir, I have one question here.
Yeah.
So while choosing the path, is it necessary that 0, 0 should satisfy that equation?
Yeah, because you are. I want to find it at origin. That is the question.
Yes, yes.
Right? So if I want to find it at 1 comma 3, then you should remember that this 1 comma 3 should lie on the path you are choosing.
Okay. This is the only single condition that we should mind. We should like
Right,
follow.
right. Because you should approach this point, right? So the
Yeah.
path should follow this path, this point.
Yeah. Yeah.
Otherwise, how can we approach
And
it?
another thing, let's
Yeah.
say the power instead of 1 or 2, if power is 3, then what kind of equation we should consider?
Y equal to x cube or x cube equal to y.
Okay. Okay. Yeah.
This type of mainly till cube you will find something, whatever the question will be.
Okay.
Okay. So this is basically giving you an idea that there may be some point where only straight line are not enough. There can be some other kind. Okay, so that's why we need to focus on what is the degree on above and below for this rational equation. Clear?
Yes, sir.
Okay. So this f is not continuous at 0, that we got. Is g continuous? The g function here.
Yes,
sir,
it's
it is.
Yes, sir, it's
polynomial. So
continuous.
It's polynomial. We have already said that polynomial this function. So this limiting value is always 0, right? At
Yes,
origin.
sir.
So this gxy, this is 0. And at 0, 0, it is given as 0. So it matches. So it is exactly g of 0, 0. So it is continuous. So g is continuous, but f is not. So option 3 is the correct option.
but an option like for G, instead of 0, like X, the second condition it was given as 1.
Right.
Then that
Suppose
will
it
be
is
continuous.
given as 1, then it is not continuous.
Then it's
Although
not
limit
continuous.
exists at
But
0.
mm,
Okay.
yes, sir.
Any doubt?
Sir, so for polynomial, the limiting value always should be 0, right?
Limiting value always exists. You should calculate on the function.
Okay.
Why it always will be 0? It may not be, right? Suppose I give you this polynomial. What is the limiting value at 0, 0?
3.
3.
3. It is not necessarily always 0.
Okay.
We just
But
put
value
0,
should
0
exist.
in there.
But the value should exist, right?
Value will always exist. Limit will always exist. That is the point.
Okay.
Right? Now it depends how the function is defined. Is it defined part-wise? Then you can say whether it is continuous or not. All this will come. Okay? But value should exist. Limiting value should exist. And that is exactly the putting the value where you want to find the limit. That is what you want. Clear?
Yes, sir.
Yes, sir. Yes.
Okay, great. So this is the first topic which was discussed, I think. Anything else? So I will send you the PDF. You solve this problem also. Okay. This is G composite. You
Sir,
remember
what
how
is
to
this
calculate?
GOF? Is it function composition?
Yeah. Right. G composite. We have done it in Maths 1. So let me do it a little bit. So can you tell me what is G compose F here in this case? So G
We are
is
not able to
defined.
see it properly. So.
Is it? Is it
What
fine?
what
Means that
Yes,
G
yeah.
expression is too
degree we
tiny.
cannot see, sir.
If
Zoom
you
in.
zoom in little bit. Yeah, that is fine now.
Now is it clear?
Yes, sir.
Ah,
Yes.
yes,
Yes,
sir.
sir.
Yes, sir.
So there are two parts for G, right? For origin it is 0, for not for origin it is defined. So when I am talking about G composite, there will also be two parts because G is defined that way. So when it is not origin, then the function is G will be this x square minus y square by x square plus y square. Correct? So G compose F means what? First I have to do what F is. So G of what is fxy? It is always
X square comma
Square
y
comma
square.
y
X square comma y square.
Now
So it would be x4
X4.
minus y4 divided by
X raised to 4
plus
plus y raised to 4.
when it is when
Non-zero.
non x and y are not
x,
0.
y,
non-zero, and when 0 x and y both are 0, that
It
is
will
at
be
origin,
0.
it will be 0, right? Whatever the value is, it will be 0. So this is the function, option 2. Correct?
Yes, sir.
Everybody
Yeah.
got this?
Ah,
Now we are
yes.
asking the question.
Can you just do it one more time, please?
Okay. So first I am applying f. Okay, fxy.
Yeah.
What is fxy? It is x square.
X square, y square. Yeah.
Now I have to apply g on that.
Yeah.
So now my variables are x square and y square. These are my inputs.
Yeah.
So gxy you have defined as x square minus y square by x square plus y square. Now instead of x I have x square, instead of y I have y square. So
Correct.
it will be x4 y4 by x4 plus y.
Plus y. Okay, yeah.
Yeah, that is what I have done. And for 0 it is 0 because for origin g is 0. So whatever x square y square, whatever is the input, the output is 0.
Okay,
Okay,
yeah,
I got
got
it.
this.
Okay. So option 2 is our function. Now I am asking you different limit for this. Right? Different limit for this. So my question is for this function, is does limit exist at origin?
Say second path dependent.
Yeah. And see, here also both numerator
Rational
divisor has degree
function.
4. Rational function and both of them are
Yes.
degree 4. Same degree. Right? So I can easily choose y equal to mx. And for
X1
different
upon
m,
M.
I will get different values. Correct? Anyone has any doubt?
No, sir.
So this is what I will get. Right? So x4 will cancel out. So 1 minus m square by 1 plus m square. So basically for different m, I will get different limiting value. Right? If I take y equal to
Sir, what
x,
you have done here, y is equal to mx. After that, what you have done?
I have just put the value in the function. So if I am
This is
approaching
GOF of xy.
G composite, right? I am talking about this function.
Okay, instead of y, you are writing m4 x4.
Because I am approaching via this straight line, y equal to mx, right?
Hmm. Okay,
Suppose
got
say
it.
y equal to x, forget about m, y equal to x.
Hmm.
If I am approaching via y equal to x, what will be our function look like? This is x
X to
square
the power
minus
4
x
minus
square
y
by
to the power 4.
ah. So instead of y should be equal to x, right? That is the path I have
Yes,
chosen.
so it will be x to the power 4.
This one, right?
Yes.
So 0
Yes,
by
yes.
2, 2x power 4. So
0
it is
by
0.
2x to the power 4.
Right? And what happens if we choose this path, y equal to 2x? Can you tell me?
Then x to the power 4 minus 2 to the power 2x to the power 4.
That is 16x to the power 4.
16x to the power 4, yeah. X to
And
the
this
power
one.
4 plus 16x to the power 4.
So x to the power 4 will cancel out. So minus 15 by 17.
Yes.
Now for two path I am getting two different values, limiting values. Correct?
That means that limit
Limit
not
does not
exist.
exist.
The
Clear?
limit does not exist, right?
Yes.
Yeah. Clear? Is it clear to everyone?
Yeah,
Yes,
this
sir.
is clear.
Okay, great. So this type of question was there. Let's see.
So can we conclude here saying that whenever you get same value, it means that the limit exists, and you can find that. Whenever the values are different, then we say that the limit does
Oh,
not
same
exist. Right?
value also does not guarantee that limit exists.
Okay.
Because there are infinitely many. So that's why I have
Correct.
given this example, no?
Yeah,
You
yeah.
choose any state line, the limiting value is 0. It is always same. But that does not guarantee that limit exists. Because there is another path, y equal to x square,
Correct.
for which the limiting value is 1. So there is a path where limiting value is not matching.
Yeah.
Okay, so limit does not exist in this case also.
So,
So
sir,
even
how to
suppose
choose this type of path?
what?
How to choose this type of path? For example, here in this case, we are choosing y is equal to mx, we are getting 0. Like if I say y is equal to x, then also I will get the means
0 for whatever value
yeah,
of
0.
n. Yeah. So for all straight line you will get 0 here. That is
Yes.
the point. That is my point. For all straight line you will get 0.
Hmm.
So now you have to ask, can there be any other path for which limiting value will be different? So what I have said earlier, so there is a difference between the degrees, right? X
Yes.
square and y. So difference between degrees. So we should move to the higher degree curve. So the first
Okay.
higher degree curve we know is parabola, right?
Hmm.
Y equal to x square. That's why I have chosen that.
Okay.
Right. Suppose I have give you this function. Say fxy is x cube by y. then for parabola also you will get 0.
Yes.
What is the next curve you
Cubic
need?
we have to go.
So that degree will give you an idea what path you should choose. There is no exact rule for that, but that should come via practice and intuition, nothing else. And
Okay,
the
so
degree
here
will
in this
suggest
case,
some path.
sir, then here in this case, then if we choose y is equal to x cube,
Exactly.
then we
That
will
curve
get
will
one.
give you exactly.
Okay,
Understood?
sir. Yes, sir.
So the degree will give you a hint what path you should choose.
Okay.
Okay. Okay. Great. So this thing you can do better. It's also, I think, yeah. For this one, can you tell me whether limit exists or not? So option is already pointed out, but can you give me the path whether limit exists for this function? Can you see the function?
But the YouTube link is not working.
I will see that later.
So in this case, if you put y equal to x, and then let's say if it is
So
0,
So it's again path dependent.
yeah, it is dependent.
So give me two paths. So if
y
the
equal
first
to
one
x,
you are saying
y equal to x square.
y equal to x. So first let me check where y equal to x. Okay.
Yeah.
So my for y equal to x, my fxy will be
X
by
upon
x
x
upon.
square plus x. Yeah. 1
correct.
upon x
Now
plus
if I am approaching to 0, my function is
you
giving me
have
1.
1 upon 1.
So for this path, I am getting
1.
1. Another one you have said
Y equal to x square.
y equal to x square. Let's take that.
X square.
Then my function is x
X
square
square
plus
1.
x
X
square.
square plus x square. 2x
So
square.
it's
Only
0.
1 by 2.
1 by 2.
1 by 2.
Oh
No, not 0.
It
It is
was
1 by 2.
sorry. It was x square. Sorry.
So it is 1 by 2. Now if I take the limit for this curve, now if I approaching to 0 via this curve, the limiting value will also be half, right? 1
Yeah.
by 2. So two different limiting value for two different curves, correct? For y equal to x, we are getting 1. For y equal to x square, I am getting 1 by 2. So limit does not exist. And then it is not continuous. Clear?
Yes, sir.
Yes, sir.
So now we have understood, at least got an idea that how we should choose the path. You can see. So y equal to x square, why you have chosen y equal to x square? Because you can see that there is a degree x square for x, but y is of degree 1. So I can extend y to a degree 2 so that x will cancel out. So that is the idea you are using, nothing else. Okay?
Sir, like
Yeah.
you gave idea for choosing path. So the bill, can you give idea for like basic solving sandwich theorem while applying sandwich theorem?
Yeah, I'll come to that. Sandwich theorem I have not done yet, but I will do that one problem. Okay, so this is clear, right? This problem is clear.
Yes,
Yes,
sir.
Sir, continuous part have you explained means how to check for continuity? Is it like how we have checked in one variable case?
Have you joined later or what? I have said at the beginning. So, yeah, it is exactly the same thing. So, this is how we have checked for continuity for one variable, right? Left hand limit and right hand limit should exist and equal. Then limit exists, and then that limiting value should be exactly f of a, right? The function value at that point. Similarly here, first check the limit exists or not. If limit exists, then the limiting value should be equal to f of a. Then the function is continuous. If limiting value does not exist, then you don't bother about what is f of a. If it does not exist, then you can directly say that it is not continuous.
Okay. Got it, sir.
Yeah. Okay, so this is what we have done. Can you tell me this one? Any idea about how to do this one?
The above degree is 4, I think, sir. I can't see properly. And the below degree is 2.
We
Let
can
me
say y equal to x square as start with.
y equal to x square.
Yeah.
Okay. Then
So if we put that, then it would be 4 x square x raised to 4. Yeah, upon x raised to 4 plus sorry, x square plus x square. Yeah. Yeah. Yeah.
So
That's
y
it.
is equals to x square. So
6
y is
will be
already
x6.
squared. So
X raised to
it will
4.
be
X6.
x.
so it should be x to the 6.
Yes,
Right?
sir.
Yeah.
Huh.
Then
So it would be 4 x raised to 6 upon x raised to 6 because you can add that, right? 2 plus
this I cannot add. This is add.
We can take
Addition.
common.
Common.
We can take common, but
X
we
square
cannot
out
add those two.
1
So
plus
this
x
I can
square.
do.
Yeah, that's fine. Yeah. So 4x raised to 4.
So this will give
0.
me 0.
Yeah.
Okay. Any other path where it will not be 0?
Sir, can we take x square equal to y square?
X square equal to y square is not a curve. That's
Okay, sir.
that is not a curve particular.
So we
That is
can take
basically
any
correction of
straight line as well, I guess, just to show
Y equal
that
to
it's
x.
not 0.
Okay, say y equal to x. Then what I will get?
4x square.
Plus x square.
Oh no, it's again 0.
It will be 0.
Yeah.
It's again 0.
Then any other path you want to try?
Sir, I guess the limit would be 0
Yeah, in this case limit exists. So
because
whatever
because
path
above degree is greater and the denominator is less. So we can conclude that. At least we
so
can guess that.
basically that will guess that that's it. Will give you the guess for
Sir,
that
can we
limit
check on
exists.
y is equal to x to the power 4?
Okay, do it.
4x square x raised to
Sir, should we
6.
check for all lines, possible lines?
Huh?
It would be 0 again.
Again
The
0.
the degree on the numerator would increase rapidly as we
Exactly.
Yeah.
increase that. Sir, I think Pooja is right, because if we use the polar theorem, I mean polar coordinate, since the numerator is greater degree, so
I don't want to
I
go to
think we
polar
are gonna
coordinate.
get.
Yeah.
No, sir.
But yeah, you are
I'm
correct.
just
You are
saying.
correct. Yeah, you are correct. That will actually give you an idea. So, do all of you know polar coordinate? Yeah.
No.
I
No,
don't
sir.
know, sir.
No. Then
Basic,
I will
roughly, we
not.
know that. So.
Then I will not bother about polar coordinate. So basically, here, what some of you have already guessed, that whatever path I will choose here, every path it will give me 0. But
Yeah.
that does not give me a proof, right? Because there are infinitely many such paths, and I am
Correct.
checking for only finitely many, whatever I am doing. So, but at least you see that what is the degree of the above the numerator? What is the degree?
4.
4.
And below
The
it's
fourth
2.
degree term. X square y
Below
square
is
is the
2.
fourth degree term, and below is 2.
Yeah.
The denominator is 2. So whatever the path we choose, the degree above is basically exceeding, right? And so it will give me 0. So that will give me an idea that okay, so there may be some reason where all the limiting values coming as same. So maybe limit exists. So now we should try to sandwich theorem. We should focus on sandwich theorem. Can we bound this function by sandwich theorem? So that is the question. Can we give me a bound for this function?
Sir, that theory we can use, that mod of x is less than equals x
So
square plus y square, and that one. Yeah, like this.
can I just write this? Because x and y, x square and y square both are some positive, right? So whatever I am adding more term here along with x square, that will be greater than x square. Correct? Is it clear to
Yes, sir.
everyone that this
Yes, sir.
statement is
Can you
correct?
repeat, sir, please? Last.
Yeah, x square and y square both are non-negative, right? Both are greater than 0.
Yes, sir.
So if I add x square on both sides of this, so I am getting this, right?
Yes, sir.
Because I am adding a non-negative number with x square.
Yes,
So
sir.
it will always be equal or greater. Right? That is what I have written. And x square is anyway greater than 0. So this part is left hand side is clear. And right hand side is also okay because y square is non-negative. I am adding another term with x square which is non-negative. So it will be greater than. Clear?
Yes, sir.
Same argument is going for y square also. Correct?
Yes, sir.
Now can we do something for this one?
Divided by x square plus y square.
Divided by x square plus y square, but before that, so if I divide on both sides, what I am getting? Yeah, you can divide, but I mean, I need x square y square, right? In the numerator.
So we can combine those two inequalities.
Exactly. So I can take the product of this.
Yes, sir. And now we can
Everything
divide.
is positive here, so no need to worry about the inequality. We can do the product directly because all of them are positive number, non-negative number. Right?
Yes, sir.
Clear? So I can do the product and still the inequality will remain the same. Right? Now we can do whatever we want. Now you can divide by x square plus y square. Is it clear to everyone or should I explain it once more?
Sir, please explain it again because I was not getting this x square y square. How we got that?
Which one? The first step? This one?
Second one.
This step?
Yes,
If you get the
zero.
first
No,
step, then
after that.
this one.
Yes.
This is the product of the above two.
But why
That's
we
the
are
product.
okay? You are just multiplying both.
And all of the why the inequality will remain intact because all of them are positive number, non-negative number.
Okay. Yes,
Right?
yes.
So the inequality will not be affected if I take the product.
Yes.
Right? If one is negative, one is positive, then inequality may be affected. But here inequality
Yes.
will not be affected because everything is non-negative here. Everything is greater than 0, greater than equal to 0.
Yes.
Right? So that's why inequality will remain same. And
Okay.
after this step, I am just dividing by again by x square plus y square. And again, I am dividing by a non-negative number. So inequality will not be affected. Right?
Okay.
So this is what I get. So this part is 0. This left hand side. This is 0.
Yes, that's 0.
This is our function more or less. A 4 is there, but this is more or less our function, and this is x square plus y square. So I can multiply 4 on all this. So I am getting 0. This is my function fxy. This is this function. Now this is my gxy. This is my hxy. Correct? What is the limiting value of gxy?
0.
When xy
Zero.
0, sir.
This is 0 because it is a constant function. It is always 0.
Hmm.
What is the limiting value of hxy when xy tends
0.
to 0?
Zero.
Zero.
And here you understand that why I have done it like this, because this is a polynomial function and we know for polynomial what are the things. Right? That's why it is important. So it is again 0. And the function which is in between bounded by these two functions, then the limiting value should be by Sandwich theorem. What is the limiting value?
Would
Zero.
be 0.
It is 0. Is it clear? How we have used Sandwich theorem for this? Is it clear to everyone?
Yes.
Yes, sir.
So this is what we need to do. Someone was asking for Sandwich theorem right before this, right? Is it clear to you? Who was that?
Yes, so like
Pooja.
basic rules, what and we have to keep in mind.
Now more or less you have understood, but mainly this type of inequality you have to use. So there is a inequality on mod, right? For mod also we can do this.
Yes, sir. From the inner product logic, we had this. I mean, somewhere there.
Square's theorem, if you remember.
Cauchy-Schwarz. Yeah, Cauchy-Schwarz inequality. Yeah, there.
So these two are main inequalities. For sine function and cos function, you also know how to use that, right?
-1 and 1.
-1 to 1.
Right. Sometimes you have to use this also. So this time, known inequality you have to use. Okay. The famous.
So like basic trick like sine and cos and this x square terms and mod. Is that enough or?
So, yeah. That's enough. And remember this degree. First, check the degree of the. I mean, you have to get an idea that limit exists, right? Otherwise, you cannot do that.
Sir,
First,
like
check
if the
idea that, yeah,
if the numerator degree is greater, then we can assume that it would
right,
be zero
right,
zero at the edge.
right. Understood? More or less, it is clear.
Yes.
Yes, sir.
Okay, fine. Not only numerator degree is greater than. I mean, that may not be always true. If I say this type of function, then also only choosing path will give you a contradiction. Right? You can choose x equal to y square.
So it does depend on the expression what we are getting in
Exactly,
the question.
exactly. Not only just seeing the degree of x and y. So here, I mean, mass things are involved. I mean, not only degree. I mean, all the x and y have same type of degree. Right? X has maximum degree 2, y has maximum degree 2. So we cannot exactly choose some particular path for this. There is no difference between degree of x and degree of y in both numerator and numerator. That is one hint you can take. Okay.
And so another thing for the given question, the numerator is the product. So each and every path we take, so the degree would get multiplied and would get bigger than the numerator. I mean, sorry, the
Yeah.
denominator.
Right. 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 That is one. Okay. Anyone has any doubt till this point?
So
No,
how
sir.
to approach the sandwich theorem for
That is
any
what
given
we
case?
discussed for last 10 minutes.
Huh?
That is what we are discussing, no?
No, no. How to given statement, how to convert to sandwich theorem? Any hints? Like you took 0 is less than equal to x square and x square is less than x square plus y square, like that.
Why I am using this? Why, that is you are asking. I
Not
mean, how I
why.
have.
How to get for any problem.
No, that depends on the problem. That is what I am saying. So here the terms involving x square and y square, right? So can we use any inequality which involve x square and x square plus y square, which have an inequality? So suppose I have given you a function like this, which involves sine function, right? Like this function. Then you know an inequality involving sine. What is that? This one,
Sign less between
right?
minus 1 to plus
You
1.
know a bound of sine. Now you should use this inequality to reach the sandwich theorem. That depends on the function which I've used in that problem. Okay?
Okay.
So
Thank
that
you.
is what you suppose a mod is involved. Then you use this type of function, right? That is one type of inequality you know. Understood?
Yes, sir. Thank you.
Yeah. Okay. Great. So this so what type of inequality you should choose, that basically you have to look to the function and what functions you are using, what the I mean, quantities you are using in that function. That is what is concerned. Okay. So this is done. There is one more thing called partial derivative after this. Can someone tell me what is that partial derivative? Anyone remember?
Derivative with respect to one variable means we have two variable, but one variable we will do the derivative with respect to one variable plus multivariable.
Right.
Keep the other
So
as
basically,
constant.
yeah.
Yeah,
So
other one will
basically,
be taken
in
constant.
one variable, we have no concept of partial derivative because there is only one variable, right? So whatever the
Yes.
derivative we have done, that depends on the that particular variable. So how f dash x was defined for single variable? If you remember, we have defined like this.
Limit f of
A
x
plus
plus
h
h
minus f
with
of a
respect.
by h.
Uh,
Yeah.
this one, how this is how we have defined. So instead of x, I should
Yes.
write a. At point A, it will be like this. Okay, this is how we have defined.
Hmm.
Now, so basically what we are doing, if you remember, so this is a function at point x equal to a, then at a plus h, I am measuring the increment, right?
Yes.
And I am basically doing this increment. This theta
Yes.
I am basically bothered about them or not. That is our derivative is actually. What is the increment at that point? So if a plus h, so this is if a plus h, this is if a, and what is the increment with respect to this increment in h? That is what we are doing. Correct?
Yes.
Okay. So same type of thing we can do in our multivariable function. So there are two variable, more than one variable now. Right? Suppose there are two variables x, y. So whatever I am doing for two variable, that can be extended to n variable. There is nothing special about two. So now if I want fx of a comma b, what does it mean? It means increment along the x axis, right? Along the x direction. So there is x, there is y, there is z, where I am getting the output. This is the field. Now I am talking about a comma b. So there is something called a of a comma b. Right? Now along this direction, along the x-axis, this direction, what is the increment of the function along this direction? That is what we are calculating. Is the picture clear to you?
Yes, sir.
No?
Are we calculating the plane here?
No, we are not.
Because you have drawn a.
The direction of x you're calculating, right, sir?
Okay, direction.
So let me draw it little bit clearly. This is x, this is y, this is z. So this is not a plane, this is some surface. This. Suppose this is my point x equal to a comma b. X y equal to a comma b. Okay, so this is my function at a comma b. Okay. Now there are two directions along x and along y, right? This is
Yes.
along x.
Yes.
So along x, if I move, a functional value will change.
Yes.
This is what we are calculating. The rate of change along this direction.
Okay.
This is my f of
Got it.
x. What is the change along this direction? And if I do it on this y, this is what we are calculating.
Then it will be along
What
y.
is the change of function? Okay. This is what we are doing. And for directional derivative, as I am drawing this picture clearly, directional derivative, we do, suppose any vector, this is another vector, right? So along this direction, we will do the change. We will calculate the change. This is the directional derivative along that vector. Yeah.
It's generalized case, we can say, right?
Generalized case of, For partial derivative, we only moving toward x-axis or y-axis.
Y-axis.
For directional derivative, we choose any vector u, and along that direction, we are calculating the change of the function.
Okay.
Is it clear?
Yes, sir.
Yes.
At least diagram-wise, what we are doing, is it clear, right? So,
Yes,
same
sir.
thing.
So this diagram is clear.
Yeah, great. So if x, a comma b, is basically along x-axis, right? So we only focus on x. Along x direction, what is the change? The same type of definition I am writing, if you can see. Right? This. Only along x direction I am calculating the change, if you see. The y direction even fixed. Similarly, what is f of y? Along y direction,
So
I
B,
will change the calculation.
yeah, b plus k, and a would be intact.
Exactly. Clear?
Upon k.
Now, and in the same line, can you tell me what is the directional derivative should be? What is the directional derivative? So u is the vector, u1, u2. Okay? Because we are in R2, right? So u will be some u1, u2. Now we have to bother about both this direction, right? u1 and u2. Suppose this is a unit vector. Otherwise, we can divide it by norm. Correct? If it is not
Yes,
a
sir.
unit vector,
Yes, sir.
we know we can divide it by norm and to get the unit vector. Correct? So if it is a vector v, then I can divide by norm and it will be a unit vector. Correct?
Sir, are we dividing unit by unit means making it a unit vector? Because if we know what happens to our unit vector, we know that what will happen to every
Exactly.
point in
Exactly. Every
space.
point on that direction.
Yeah.
So only the unit vector is enough, right?
Hmm.
So if I know what is happening on 1 comma 0, I know what is happening in h comma 0.
Yes.
That is what it is.
Hmm.
Okay. Because so here also we have done the same thing. So I will go back to this again. But before that, limit what it should be a plus HU1, b plus
B plus
HU2.
KU2.
HU,
Sorry,
Yeah,
K.
yeah, H.
K. No, you are right.
KU2.
KU2 minus f of AB by what will be there?
HK.
How we should write that then? What we are doing here? What we want to write here? What is this?
Limit as h tends to 0.
Hmm.
So
So that okay. So a plus h minus a, that gives us h. So that thing we
Right.
gotta write below there. A plus h minus a, or a plus h plus b plus k minus a minus b. So h plus k.
So what it will come here actually? Here is a change of this direction, right? This was h here. This was k here. So what will be here?
h
H
plus
Over
plus
h
k.
square
k.
plus.
H
Under
plus
root h
Under root.
square
Sorry.
plus
Under
under
root.
root h.
Yeah, under root.
Correct? This one is what our vector, right?
Yes,
Yes.
yes, under root.
Understand? If you see the diagram, then it will be more clear. Here it is your h along x-axis. Here along k along y-axis. So what is the resultant along this? This is h square plus k
H
square
square plus K square
under
under
root
root.
of that. That is what we are writing. Clear?
So Pythagoras.
Yeah. Pythagoras or resultant vector, whatever you want. Yeah, Pythagoras is most clear. Yeah. Right. Okay. Clear? So this is, and then your hk should be 0 to 0. Okay. This is what we are doing. Now, if we
Sir,
go
I have
back,
a question.
yeah.
In the lecture which I saw earlier for the first lecture of week 9, means the revision session, the session one only. Sir
Okay.
used like f of a plus b comma h u1 u2. So we can do that way also.
Each of U1, U2, I don't think. HK of U1, U2, right?
He wrote like means earlier like how we have defined with partial derivative. He means what sir did was like f of a plus b comma h of 1 comma 0. So he wrote like that.
So that is for partial one. Yeah, exactly. So that what I am doing now. Now,
Mhm.
suppose this unit vector, I am just bothered about along x-axis. Then what is my unit
Yes,
vector along x-axis? 1 comma 0,
1 comma 0, sir.
right?
Hmm.
This is my 1 comma 0, right? So if I
Hmm.
change U1 as 1 and U2 as 0, what I am getting?
The k part would be 0.
K part would be
So
0.
k part we don't have to bother about basically. So this u part is 1, so a plus h. U2 is 0, so just b minus f of
B.
b, right? Now k part
Hmm.
don't have to bother about root over of h square, that is a. So this is exactly what my
Okay, sir.
fx is. That is I think what he
Hmm.
has done. Okay.
Okay.
This is of f of x as a comma b.
Hmm.
Similarly for y axis, what we will get? This is for 0 comma 1. Then you will get
H
A
part would be
comma
0.
A plus h.
so this is k tending to 0, f of a comma b plus k minus f of a b by k. This is what. Okay,
Yes, sir.
understood?
Yes, sir.
Okay, great. So this is what we have done. So If you want to revise this, you just go to the solve with us assignment. I think everything is written there. What I have remembered. So let me open solve with us. It's not there. If you see the solve with us assignment of week, it is in week 9, right? Directional. So if I say this one, so whatever we have discussed, more or less all type of problem you will see here.
Okay.
The definition.
Sir, can you briefly touch upon the gradient also?
Yeah, I will do that. Oh, I am. Yeah. This one. Okay.
Yes.
This one is the directional derivative. Now here, yeah, this one if you see. So here everything h and k, all of them are shifted towards h. That is what you are saying, correct?
Yes.
This one. So yeah, for Rn what we are doing now. This part is clear, more or less, what I have done here till now.
Yes, sir.
Yes, sir.
Right. Now, if I just take my increment on both sides as same h, same quantity, will that affect my limit?
That
Will that
shouldn't
affect my
affect
limit?
the limit. It will still not, because it is a very small quantity which we are doing.
Exactly. So for both direction, I really don't need two variables. That will easier my calculation. Correct? So I can just only focus about one thing. We don't have to need h and k as different, because anyway we are going to 0, 0. So I just want to take h tending to 0. I don't have to bother about two different variable here. I can just replace k and h as the same thing. So I need only one thing, nothing else. Okay. But this h and k will be more useful in your week 11 when you will do the derivative, the total derivative of that. Then we need this both h and k. But for directional derivative, it does not really change our calculation, because h and k both are tending towards 0. So we can focus on the same h for all the variables. Clear?
So wouldn't we have
Yes,
like
sir.
root 2h, or it doesn't matter?
It is again going to 0, no? Root 2h or h.
Yeah.
Both of them are going to 0 on the same place, right? So it will not matter. It does not matter actually. Correct? So basically, suppose what I will say. Suppose f, limit of some function, right? X tending to 0, and 2f. It is just multiply with 2, right? Whatever the limiting value. Now, if it is going to 0, then it will also go to 0, right? The scalar product doesn't matter. Clear? Is it clear what I am saying? So
what did
Yes,
you
sir.
say?
let me say it again. So you are saying root 2h. If I am saying h tending to 0, what is this limit?
Zero.
It is
0. And if I say just this,
still
does
0.
it changing anything? No. So this quantity, scalar quantity, doesn't matter actually. I can take it outside.
Okay, sir.
Yes, sir. The constant we can do.
Yeah. Okay, fine. So this is what we are using.
Sir, today's session, will it be uploaded tomorrow?
No, actually, it is recording
It is
anywhere.
recorded, but I could not see it. I think
It is
it's not.
not. It is not
It is not
showing
streaming.
live
It
as
is
it
not.
usually does. It is
Yes,
not
sir.
streaming. It is getting recorded, but it is not streaming as of now.
Yes, also I want to revise the quiz answer solution.
Some problem is there in live streaming. Yeah, I will upload this recording then. Okay. It will be recorded by tomorrow. Okay.
Okay, sir.
Don't forget, sir, I want to revise.
Okay. So is it clear more or less what we have done till now?
Yes,
Yes,
sir.
sir.
Yes.
Yeah, and there is something called gradient. What some of you are saying, gradient vector. What is this? This is basically
So the row vector form of the partial derivatives.
so suppose there are n variables. So this is the gradient vector. Okay. So for two variable, it is just fx.
fx comma fy. Okay. Sir, but what does it mean? Means we are taking gradient, we are taking partial derivative. So that means that we are means shifting with respect to x or y, right? X axis or y axis.
What does the vector mean, right? That is what you are asking.
Yes, 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 sir.
Okay. Fine. So yeah. So let me go to GeoGebra now to show this. Okay. So till now, whatever discussed is clear, right? More or less.
Yes, sir.
You'll have to have have to go through the video again one more time. But yeah, most of it is clear.
Yes, so mostly it is clear, but yeah.
Will you be sharing the quiz 2 solutions as well, the one which we solved today?
Yeah, I will share the whole page.
Okay, thank you.
Can you see this?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So this is one interesting demonstration you can see. So I have taken a surface x square plus y square by 2. This is whole by 2. Okay? X square plus y square whole by 2. And the point I have fixed 1, 1. Okay. A vector, any vector I have chosen. Suppose it is 0.71, 0.71. The vector. So this is basically the vector which is making an angle of 45 degree. Okay. With the x-axis. So you will do the calculation and get a directional derivative, correct? And there is a way to find the directional derivative, including the using the gradient vector, if you remember, right? That is in the first or last lecture of week 9, right? The dot product of gradient with
representation.
The
Yeah, representation.
Right? The dot product of gradient vector with the unit vector.
Yes,
correct? That
with
is
the normal unit vector.
With the unit vector, right?
Here,
anyone has any doubt in this? So what
No,
I am saying, so if you remember du of f xy, so this I think grad of f dot u, this I can do, correct? This is what we can do to find the directional derivative. This is one easier way to find, but here the condition is this should exist. All these partial derivatives should exist. Otherwise, we have to go by the definition. Okay. So I will come to details of this, but there is a way to find this. So there the gradient vector is one of the application of gradient vector is coming. Okay. So here what is happening? If I change my unit vector, if I change this unit vector, you see this plane is moving, right? You can see the plane is moving, and this straight line, which is basically a tangent at that point. So this back point, which you are seeing here, that is 1, 1. right?
Okay.
And this on this plane, this straight line is basically tangent on this plane, which is, and how the plane is created? The plane is basically in the direction of the vector we are seeing. So the slope of the tangent is basically our directional derivative.
Okay.
So like putting stick on the top.
Putting stick on the top means?
The direction it travels, we slide a stick on that. Is it like that?
Basically, yeah, right. So basically, if you take, so this red vector you are seeing here, my cursor, can you see?
Yes, sir.
Can you see my cursor in the live? Yeah. Okay. So this direction is basically the vector. Right? Along this vector direction, I am calculating the directional derivative, and this is my point. So if I draw a perpendicular from that point on xy plane, right? This is my point 1, comma 1, and this point is basically 1 plus 1. So this is 1, comma 1, comma 1. This point.
Okay.
Right? Because if we put 1, comma 1 in the function, the output will be 1. Correct? So this point is basically 1, comma 1, comma 1. And this point on xy plane is 1, comma 1. And
1,
at this 1, comma 1, if I take the unit vector in that direction, I can draw this plane which intersect the surface. And at the point where it is intersecting the surface, that is the point 1, comma 1, comma 1 for this particular point. And along that plane, I can draw a tangent. So there are infinitely many tangents on that point. But along that plane, there will be a particular tangent. And the slope of that particular tangent is basically our directional derivative.
Okay.
Now you can relate with the picture which I have drawn earlier. The rate of change of the slope, right? At a particular point along that direction. That is basically the slope of the tangent. Right? If you remember in one variable, that is what we did. The slope of the tangent is
That is
basically derivative of the function.
Yes,
at a
yes.
particular point.
Slope of the tangent.
So
one
here at a
definitely
particular
means
point, there are infinitely many tangent lines.
Yes.
So which tangent line I am talking about? That's why I need a particular vector.
Okay.
Then only I can talk about particular tangent line, and that slope of that particular tangent line is basically our directional derivative.
Okay.
Because on that direction we are calculating the slope.
Got it.
Is it clear to everyone?
Yes, sir.
Yes, sir.
Either we take on x or y axis partial derivative, or we take it with respect to a vector.
Right. Partial derivative is also one kind of directional derivative. Right. So if you see the tangent, the direction, if you are moving, the vector we are moving like this, our tangent line will be moving. Let's see. Clear? This is how the tangent line is moving. This is 1, comma 0. The vector now is 1, comma 0. Correct? So this is your partial derivative. The slope of this tangent line is your partial derivative along x-axis. Can you see?
Yes, sir.
This now line is now parallel to x-axis. You can see the vector. The vector is now parallel to x-axis. Correct? At the point 1, comma 1, this is your tangent now. And the slope the tangent is making, that is your directional derivative along that, and that is your partial derivative along x-axis. Is it clear?
Yes, sir.
Yes, sir.
Okay. You can see this. Here you can see it better. Yeah, this. Correct? This is what you are seeing. Now, if I move the vector again, this is 1, comma 0, so we return to the same point where we should come somewhere in 0, comma 1.
It's at 90, I guess it would be. Yeah.
Okay.
90 degree.
Now this is, now the vector you can see is parallel to y-axis, right? This is y-axis, this is the vector you are seeing. And now this is the plane. So plane is also parallel to yz plane. And now this is your tangent line, and the slope is partial derivative with respect to x-axis. Is it clear?
Sir, but what plane represents here?
So plane means here, so at the point 1, comma 1, if you take this unit vector, right, along this unit vector, now draw the perpendicular to that point, particular point along the vector. That will be a plane, right? Passing through the point
Yes.
1, comma.
If
That
it's
plane I
in
am.
3D, then it will be a plane.
Exactly. So that plane I am talking.
Okay, okay.
At particular point 1, comma 1, you have fixed a vector, right?
Yes.
So the plane passing through that point along that particular direction, that will be a plane.
Okay.
That plane I am. Okay? And that plane will intersect your surface.
Yes, that is.
And where it is intersecting the surface, that will give you a curve on the surface, a particular curve.
Okay.
And the point 1, comma 1, comma 1 will be on that particular curve. And that on that particular curve, you can draw a tangent line. That tangent
So
line.
that curve is a two-dimensional, means how we used to draw it, like.
Right. So on particular plane, that curve is a two-dimensional thing now. So we can talk about tangent,
Yes,
a
we
particular
can
tangent
talk
at that
about
point.
tangent there.
Yeah, that
Okay,
is
sir.
another way to visualize it.
Mhm.
Is it? Yeah. So this is a very good visualization of directional derivative. So till now we just seeing some formulas, some how to do it, some abstract definition. But now I think it will be more clear to you. Now the interesting point is, so I can move the point also in this picture. Right? So instead of 1, comma 1, I am changing the point like this. Then also the tangent will change. Now the vector is fixed. I am not changing the vector, but the point is moving. Okay. By changing this parameter, I can move the point. Yeah, now you can see how the plane is moving if I change the point. Because the vector is fixed, the direction is fixed. You can see the red arrow. This red arrow is fixed. It is always parallel to y-axis. But the point is moving. So the plane will also move along the surface. So the tangent will also move. That's why the directional derivative will change. So it does not only depend on the direction of the vector, it also depends on the point. So it depends on both the point and the direction of the vector. Is it clear?
Yes, sir.
Yes, sir.
Anyone has any doubt in this? Anyone has any doubt in this? No?
No, sir.
No, sir.
Okay. So I am pasting this in chat. If you want, you can see it, copy it, and see it later. Anyway, I will give you the PDF. There you can see. Okay. So this is what directional derivative is. And what gradient was doing, gradient is basically the normal at that particular point. That is the gradient. The perpendicular to the plane, that is your gradient. Okay. So if I go back to this again, so at this point, okay, if I draw a perpendicular to that plane, that will be our gradient vector. Okay. Who was asking about the significance of gradient?
Real world.
I was asking, sir.
So gradient is basically along at this point, if I draw a perpendicular to this plane, that will be our gradient. So gradient is basically perpendicular to the tangent plane. That is your gradient. Okay. If I have a tangent plane, gradient is the vector. This is a vector which is perpendicular to the tangent plane.
Okay.
Okay.
Yes, sir.
Okay. And that is why it is giving me the this direction.
Means that's why we are getting this vector because we are multiplying the directional component with the unit component.
Exactly.
Okay.
Understood?
Yes, sir.
Okay. So basically, more or less, we discussed our whole week 9, I think. No?
Yes,
Anything
sir.
left here? And so this question, if you see, fx and fy at origin, I have to calculate. How you should do? So here mod x is given, right? So for x positive and x negative, we have two type of thing. When x is positive, it is plus x, and when x is negative, it is minus x. Correct?
Yes, sir.
So a function is defined case-wise in this case. So for this type of function, you should go via definition. That will be better. Right? So your fx, for this case, your fx, you should go via definition. H tending to 0, x plus h, y minus fxy by h. Okay. Now what is this function now? So at origin I am talking about. So what is my point? X and y, 0 comma 0. So this is 0 plus h. And this is 0 comma 0. Okay. So what I am getting? Limit h tending to 0. F of h comma 0 minus f of 0 comma 0 by h. Now what is f of 0 comma 0? This is 0, right?
Yes, sir.
Mod x is 0 and this is 1. So 0. What is h comma 0?
So it's h into 1 plus 0. So it's h.
Mod h.
But mod h,
Mod h, sir.
actually. Mod h.
Mod h, yeah. So it is limit h tending to 0, mod h by h. Now does this limit exist?
No, sir. We have two cases, and both the cases would give us different answers for limit.
Exactly. So when h is 0 plus from the right hand side, right? When we are coming from the positive side of h, we will calculate the increment from the positive side of x axis. Then mod h is plus h, so it is 1. So I am writing it here. It is tending to 0 plus. Then mod h is h, so it is 1. When h is coming from the negative side, mod h is minus h. So
Minus h.
minus h by h. So it is minus
It will
1.
give minus 1.
So this limit does not exist. So fx does not exist.
Okay.
Got it? So there can be a function where the partial derivative may not exist at some point. So this is one such example. So the point is, if I give you this function and tell you to calculate the directional derivative at the point origin, you cannot directly put that formula grad f dot u. You cannot do that because grad f does not exist in that case because fx does not exist at 0 at origin. Understood?
So there is no directional derivative then?
No, you can calculate directional derivative, but you have to go by the definition and check whether directional derivative exists or not. You cannot directly apply the formula. Because for applying the formula, you see, if you see the lecture, Sir has mentioned this also. So for applying this formula, first you need to check all the partial derivative exist or not.
Okay.
Okay. Then only you can apply the formula. Otherwise you cannot. Right? So for polynomial type of function, there is no issue because all the partial derivative will exist. So you don't have to bother really for polynomial type of function. But when this type of function is appearing, then you have to really be cautious. You have to see whether partial derivative exists or not first. Then you can apply this formula. Otherwise, it is better to go via definition. It will always happen. By applying definition, you can always conclude whether the directional derivative exists or not.
Sir, this is the definition, right? H of 0, f of 0 plus h comma.
For directional derivative, I have given the definition. No?
Oh, directional derivative formula we have. Okay.
This one.
Any real application of this gradient?
So I think for the same function you can check fy also. Right? I am not doing that. I am doing that. Yeah.
Can you hear me?
Any doubt?
Hello?
Yeah.
Is there any real world application of this directional derivatives for inspiration?
Many real life application.
Yes.
So one thing I think this is already in your syllabus. What is called gradient descent, right?
Yes, gradient descent, machine learning
Gradient
algorithm.
descent,
I was having this doubt that is it the same thing? Means are we applying the same gradient there?
Yeah, same gradient.
Okay.
So what is gradient descent basically? So this is basically the first lecture of week 10. I think week 10 is discussed by Sushmita. I think she has mentioned it also. So when this directional derivative is maximum, right? So why we did that first of all? So what particular type of example or visualization which we generally did? That is, suppose you are climbing a mountain. Okay? You are climbing a mountain, but there is fog around you, mist around you. You cannot see what is 5 meter in front of you. So what you generally do at the point where you are standing now, you just look at the surrounding of that point on the 5 meter radius. You can see only this much portion, right? And along this much portion, you will choose the easiest way where the steepness is minimum, right? For the climbing. Suppose in this direction the steepness is minimum, you come here. Then again you choose the neighborhood 5 meter and check the where the steepness is minimum, and this way you are climbing the whole mountain. But the path you are using, that may not be the easiest path, right? Because at each point you have seen only locally 5 meter around you. You are not seeing the whole picture, right? But still it will give you a confidence to reach at the peak by using a more or less easy path, because at each particular point you have chosen the more or less which is less steep path, and you have done it like that, right? So this is what gradient descent does. You are looking at a curve, maybe it is some interpretation of some data set, right? It is giving you a curve, and now you want to find where the changes are minimum. You want to, suppose you want to find some particular way to interpret the data where you need to know where the changes are not, which are not so much fluctuating, right? You want to know such parameters. So you will check locally at some particular point where the directional derivative is becoming minimal. Or suppose you want to know some parameter where you need to know where you need to know where it is fluctuating very much. Then you need to know where the directional derivative is maximum, right? And that you will do for some local points, and you will conclude that okay, for these many parameters the data is fluctuating very much, or for this many parameter the data is not so much fluctuating, right? So that is one application of gradient descent, and that entirely depend on directional derivative. That means the gradient and some particular set of vectors. Is it clear what I have said? At least
Nice, sir.
do you get some motivation why we are doing this? Understood?
Yes, sir.
Okay, great. So this is what is the motivation we are in gradient descent. Now for directional derivative, when we are calculating this one, so what we have done, we have done this into u. U is the unit vector. Now when it will be maximum, can you tell me?
So the
Which
same
When
direction.
in the same
I mean, the
direction.
gradient and the unit vector should be facing the same direction.
Yeah, and why is that?
So actually, these two, I mean, unit vector and the gradient, these are actually fixed. So if we take it in the angular side, so it actually depends on the angle in between them. I mean, if we take the norm
Exactly,
of the two,
exactly.
so it depends on
So
the
this
theta
is
value. I mean, cos
basically,
theta.
this is dot product, right? Exactly, cos theta. This is basically norm of gradient vector, norm of u, cos theta, right? Theta is the angle between this and this. This is one you know because we have chosen unit vector. So this is just norm of this into cos theta. Now when it is maximum, this is fixed. Gradient vector norm is fixed. Now when this cos theta is maximum,
It's 0.
When theta is 0.
theta is
Zero.
0, right? So 0 means what? The angle between this and this should be equal. I mean, they should be parallel. Sorry. They should be parallel. They should be in the same
Parallel.
direction, right? So it will be maximum when the gradient vector and the unit vector should be in the same direction. That's why along the gradient vector, this directional derivative will be maximum. And when it is minimum, when theta is 90 degree, right? This is, sorry, not 90 degree, the
That is
opposite.
180,
orthogonal
180,
actually.
180 degree,
180.
right?
180,
Minus what?
pi.
Right, pi. So it is in the opposite direction. So when it is 0 degree along the same direction of the gradient vector, then the reaction derivative is maximum. When it is on the opposite direction, then cos theta is -1, then the reaction derivative will be minimum. Is it clear?
Yes, sir.
And the maximum reaction derivative is norm of this, and the minimum reaction derivative is
Minus norm of
norm.
Minus norm of this.
Minus norm of this.
Yeah, clear? So this is basically your gradient descent. Yeah, and this has a lot of application in your machine learning algorithm. Okay. As I have tell you this story of this climbing the hill, this is what exactly we do in machine learning with the gradients. Okay, clear?
Yes, sir.
Anyone has any doubt?
Yes, sir.
Okay. So let me stop here today at this point. Okay. So we will discuss this question in the next session maybe.
Is there any book for this multivariable calculus like for linear algebra there is in the course?
But whatever is there in Solvitas assignment, that is enough.
Okay, sir. Then.
And I will suggest you to play around GeoGebra a little bit with multivariable. That will clarify your idea. So today I have posted a link, right? I will post some other link also later, and just take a look around those, because visualization will be very important in this chapter. Formula you can anyway remember or somehow you can understand, but visualization is really important in multivariable.
Okay.
So then, I mean, the one topic which I have not discussed today, that is tangent line and tangent plane. But I think Sushmita has discussed this. No?
Yes, sir.
Okay, great.
Sir, is ellipse, hyperbola, those things are important in this?
Not really. We are not talking about particular type of function in this case. Okay. So, any doubt? Whatever we have discussed today, you can ask. Otherwise, we can close the session.
So when we say gradient is continuous, that means gradient does exist at that particular point, right?
And also at each fx or each variable, it is continuous. I mean, fx continuous, fy continuous.
Derivative
I mean
exists for
that's
each
the thing,
variable.
right? I mean
And not only
for
exists,
each.
but it also continuous. That is the point.
Okay.
Okay. Yeah.
Okay.
Okay. Great.
Thank you, sir.
Yeah.
Thank you.
Yeah. See you.
Thank you, sir.
Yeah.
Good night, sir.
Thank you.